conditions. Changes around us. We observe many changes in our daily life. Some are temporary changes and some are permanent. Temporary changes are called physical changes. Permanent changes are known as chemical changes. Let us classify some changes happening around us as physical changes or chemical changes and note our observations in a tabular form. Ice changes into water. It is a physical change as the chemical composition of ice and water are the same. Milk is set into curd. This is a chemical change. The chemical composition of curd is different from that of milk, and we cannot get milk back from curd. Ripening of fruit. This is also a chemical change as we cannot get the raw fruit back from the ripened fruit. The chemical composition of the ripened fruit is different from that of the raw fruit. Steam is condensed. This is a physical change. Steam condenses and becomes water. The chemical composition of steam and water are the same. Your respiration. It is a chemical change. Respiration is a process that takes place inside living things while living things breathe air in and out. During respiration, the oxygen that we breathe helps in breakdown of food and provides energy for the functioning of our body. Whenever a chemical change occurs, we say that a chemical reaction has taken place. Let us perform some activities to understand what is meant by a chemical reaction. Activity. Take a spoonful of copper powder in a china dish. Heat it strongly. What do you observe? The shiny copper powder has changed to a black-colored substance. Copper reacts with oxygen in the air to form black-colored copper oxide. This change is a chemical change. There is no change in the state as both copper and copper oxide are in the solid state. In this reaction, there is a change in color and temperature. There is no gas evolved and no change in state. Activity. Burning of a ribbon of magnesium metal. Take a ribbon of magnesium metal. Let us ignite the ribbon in the presence of air. The magnesium ribbon burns with a bright flame and a white powder is formed. This white powder is a new substance called as magnesium oxide. In this reaction, oxygen combines with magnesium to form magnesium oxide. Burning of a magnesium metal is a chemical change as a new substance, that is, magnesium oxide, is formed. In this reaction, there is a change in color and temperature. There is no gas evolved and no change in state. The magnesium ribbon usually has a coating of basic magnesium carbonate on its surface. This is formed due to the slow action of moist air on magnesium. Before burning a magnesium ribbon in air, it is cleaned by rubbing it with sandpaper to remove this coat so that it can readily react with the oxygen in the air. Activity. Take a barium sulfate solution in a test tube and add a few drops of potassium chromate solution to it. What has happened to the colorless solution of barium sulfate? a yellow solid separates out from the solution. This is called a precipitate. There is a change in the state. The original solution was in the liquid state. Now, a solid has separated out from the solution. There is a change in state from liquid to solid. Barium sulfate reacts with potassium chromate to form a yellow-colored precipitate of barium chromate. This is a chemical change. There is a change in color and also change in state. There is neither any gas evolved nor any change in temperature. Activity: take some powdered ferrous sulfide in a test tube. Add to it a few drops of dilute sulfuric acid. What do you observe? The solid ferrous sulfide slowly disappears and there is evolution of a gas. The color of the solution has also turned green. This shows that there is a change in state, change in color, and also evolution of a gas. Does the gas have any odor? Yes, the gas smells like rotten eggs. Now, touch the test tube. The test tube has become hot. This indicates that there is a change in temperature also. Let us see the reaction. Ferrous sulfide reacts with sulfuric acid to form ferrous sulfate and hydrogen sulfide gas. This is a chemical change. There is a change in color, evolution of gas, change in temperature, and also a change in state. From these activities, we can say that a chemical change or a chemical reaction takes place if there is a change in the state, temperature, color of the reactants, or sometimes if there is evolution of gas. Every chemical reaction is represented by a chemical equation. Let us understand what is a chemical equation and why it is necessary to represent chemical reactions in the form of chemical equations. What are chemical equations? Heating of copper can be represented as copper plus oxygen gives copper oxide. This simple form of representing reactions in words is called as a word equation. We can make this word equation more precise and concise by using the chemical formulae. We can represent heating of copper as Cu plus O2 gives CuO. The representation of a chemical reaction with the help of chemical formulae is called a chemical equation. Let us understand how to write a chemical equation. Writing a chemical equation. When copper is heated, it reacts with oxygen in air to form copper oxide. In this reaction, copper and oxygen undergo a change and hence are called as reactants. The new substance copper oxide so formed in the reaction is called as the product. The reactants are written on the left-hand side and the products are on the right-hand side of the equation. An arrow pointing towards the products is inserted between the reactants and the products. It also represents the direction of the reaction. A plus sign is inserted between two or more reactants or products formed. If reactions are carried out under specific conditions of temperature, pressure, using a catalyst, etc., then these conditions are mentioned on the arrow. In the heating of copper, the word heat is mentioned above the arrow to indicate the process of heating required for the reaction to take place. The chemical equation can be made more informative by mentioning the physical states of the reactants and the products. Copper is in the solid state, hence the letter S in brackets is mentioned. Oxygen is in a gaseous state, hence the letter G in brackets is mentioned near the formula. Copper oxide again is in a solid state, so the letter S in brackets is mentioned near the formula. If one of the reactants or the products is in the liquid state, then the letter L is mentioned in brackets near the formula. If one of the reactants or the products is a solution in water, then the letters AQ are mentioned in brackets near the formula. AQ stands for aqueous. For example, while representing the reaction between potassium nitrate and water to form potassium nitrate solution, the letter S is mentioned near the formula of potassium nitrate. The letter L is mentioned near the formula of water, and the letters AQ are mentioned near the formula showing solution of potassium nitrate. Consider some chemical reactions. Let us see how we can make the chemical equations of these reactions more informative. Reaction 1. Edible oil reacts with hydrogen gas to form fats. We shall mention the letter L near the word edible oil as it is a liquid. Hydrogen being a gas, we shall mention the letter G in brackets near the word hydrogen. Fats are in the solid state, so we shall mention the letter S in brackets near the word fats. The specific conditions of the reaction can be indicated by mentioning the word heat and the symbol of nickel, Ni, above the arrow. Reaction 2. Zinc metal reacts with a solution of hydrochloric acid to form zinc chloride with the evolution of hydrogen gas. Zinc is in the solid state, so we mention the letter S near the formula of zinc. Hydrochloric acid and zinc chloride are solutions, so we mention the letters AQ near their formulae. Hydrogen is a gas that is evolved, so we mention the letter G near the formula of hydrogen. Now, let us again consider the chemical equation of heating copper. Cu plus O2 gives CuO. Count the number of atoms of each element on both the reactant side and the product side. Enter these values in the table. There is one copper atom each on the reactant side and the product side. But there are two oxygen atoms on the reactant side and only one on the product side. Are the number of atoms equal on both sides? No, they are not. Such an equation is called a skeletal equation. Equations which represent a chemical reaction but are unbalanced are called skeletal equations. Balancing the chemical equation. Let us recall the law of conservation of mass. It states that matter cannot be created or destroyed during a chemical reaction. In other words, the total mass of the reactants is equal to the total mass of the products, or the number of atoms of each element before the reaction and after the reaction is equal. A chemical reaction cannot have unequal masses. Therefore, a chemical equation cannot be unbalanced. It has to be balanced. Balanced equations. Let us recall the equation in the experiment of ferrous sulfide and dilute sulfuric acid. Ferrous sulfide plus dilute sulfuric acid gives ferrous sulfate plus hydrogen sulfide gas. Is this equation balanced? Let us check this out by counting the number of atoms of each element on the left-hand side and the right-hand side. Enter the values in the table. There is one atom of iron on the left-hand side and the right-hand side of the equation. There are two atoms of sulfur on the right-hand side and the left-hand side. There are two hydrogen atoms on the left-hand side and the right-hand side. And there are four oxygen atoms on the left-hand side and the right-hand side. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Now let us understand the steps involved in balancing an unbalanced chemical equation. Steps involved in balancing a chemical equation. Consider the reaction between sulfur dioxide and hydrogen sulfide. Step 1. First, write the chemical equation for the reaction. SO2 plus H2S gives S plus H2O. Step 2. Compare the number of atoms of each element on both the sides of the equation. Let us enter these values in the table. There are two sulfur atoms on the left-hand side and one on the right-hand side. There are two hydrogen atoms on the left-hand side and two on the right-hand side. There are two oxygen atoms on the left-hand side and one on the right-hand side. Step 3. Choose a reactant or a product that has the maximum number of atoms in it. In this equation, we shall select SO2, that is, sulfur dioxide, and the element oxygen in it. We have seen that there are two oxygen atoms in SO2 in the reactant side and one oxygen atom in H2O, which is in the product side. Try and balance the number of oxygen atoms. To balance the number of oxygen atoms, we cannot make H2O to H2O2. In other words, we cannot change the formulae of a reactant or a product to balance a particular element. But we can change the coefficient of the deficient side, whether it is in the reactant side or the product side. We can put the proper coefficient 2 for the H2O molecule to balance the oxygen atom to get 2H2O. The equation can be expressed as SO2 plus H2S gives S plus 2H2O. Enter these values in the table. There are two hydrogen atoms in the reactant side and four hydrogen atoms on the product side. And there are two oxygen atoms on either side of the equation. Now the equation is partly balanced. Step 4. Select any other atom that is not balanced. In this equation, the S and H atoms are still not balanced. Let us select hydrogen atoms first for balancing. Try and equalize the number of hydrogen atoms as we have done earlier using coefficients. There are two hydrogen atoms in the reactant side and four hydrogen atoms on the product side. The deficient side is therefore H2S. Put the coefficient 2 for H2S molecule in the reactant side to balance the hydrogen atoms. Now, the equation can be represented as SO2 plus 2H2S gives S plus 2H2O. There are four hydrogen atoms on either side of the equation. There are three atoms of sulfur on the reactant side and one on the product side. Step 5. Now select sulfur atoms for balancing. There are three atoms of sulfur on the reactant side and one on the product side. To balance the number of atoms, put the coefficient 3 for the S atom in the product side. The equation can be represented as SO2 plus 2H2S gives 3S plus 2H2O. Step 6. Now, let us count the number of atoms of each element in the equation. There are 3 sulfur atoms on either side of the equation. There are 4 hydrogen atoms on either side of the equation. And there are 2 oxygen atoms on either side of the equation. This is now a balanced equation. This equation can be made more informative by indicating the physical states of the reactants and the products. Sulfur dioxide and hydrogen sulfide are gases, so mention the letter G near the formulae. Sulfur is in a solid state, so mention the letter S near the formula. Water formed during the reaction is in the liquid state, so mention the letter L near the formula. Let us consider some more reactions. Reaction 1. Barium chloride plus sulfuric acid gives barium sulfate and hydrogen chloride. Is this equation balanced? Let us check this out by counting the number of atoms of each element on the reactant side and the product side. Let us enter these values in the table. There is 1 barium atom on the left-hand side or the reactant side as well as on the right-hand side or the product side. There are 2 chlorine atoms on the left-hand side and 1 on the right-hand side. There are 2 hydrogen atoms on the left-hand side and 1 on the right-hand side. There is 1 sulfur atom on either side of the equation. There are 4 oxygen atoms on the left-hand side as well as the right-hand side. The equation is not balanced. Which reactant or product has the maximum number of atoms in it? Sulfuric acid, H2SO4, has the maximum number of atoms. Let us first balance the hydrogen atoms. We know that the number of hydrogen atoms is not equal on the left-hand side and the right-hand side. Put coefficient 2 for the HCl molecule to balance the hydrogen atoms. The equation can now be represented as BaCl2 plus H2SO4 gives BaSO4 plus 2HCl. Enter this value in the table. There are 2 hydrogen atoms on either side of the equation. Are the chlorine atoms also balanced? Yes, there are 2 chlorine atoms on either side of the equation. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Reaction 2. Recall the chemical equation in the experiment of heating of copper. The equation was Cu plus O2 gives CuO. Is this a balanced equation? Let us check this out by counting the number of atoms of each element on the reactant side and the product side. Let us enter these values in the table. The number of copper atoms on the left-hand side and the right-hand side are equal. There are 2 oxygen atoms on the left-hand side and 1 on the right-hand side. The equation is not balanced. If we put a coefficient 2 for the copper oxide molecule, the number of oxygen atoms are balanced, but not the number of copper atoms. Put a coefficient 2 for the Cu atoms on the left-hand side. There are 2 copper atoms and 2 oxygen atoms on either side of the equation. The number of atoms of each element on the left-hand side is equal to the number of atoms of each element on the right-hand side. Hence, this equation is balanced. Reaction 3. C12H22O11 reacts with water to give two molecules of C6H12O6. What does this reaction describe? This chemical equation describes the reaction of sucrose with water in the presence of concentrated hydrochloric acid at a temperature of 323 Kelvin to form glucose and fructose. Name the reactants and the products. Sucrose and water are the reactants and glucose and fructose are the products. Let us now discuss the different types of chemical reactions. Types of chemical reactions. Chemical reactions involve breaking and formation of bonds between atoms to form new substances. For example, hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Bonds between hydrochloric acid and sodium hydroxide break and form two new compounds, sodium chloride and water. Many chemical reactions occur in and around us. Let us discuss one such type of chemical reaction, combination reactions. Combination reactions. A chemical reaction in which two or more substances combine to form a single product is called a combination reaction. When a mixture of iron and sulfur is heated, we get iron sulfide. This is a combination reaction. Another example is the formation of acid rain. Gases like carbon dioxide mix or combine with rainwater to give acid rain. You know that concrete is used in the construction of buildings. What is concrete? When water is added to a mixture of cement, sand and gravel and allowed to set, it imparts strength to the building. The substance so obtained is called concrete. This is also a combination reaction. Tricalcium aluminate is cement. Water combines with it to form concrete. During this reaction, heat is liberated. Do you know which substance is used to make artificial ceilings? Plaster of Paris, commonly known as POP, is used in making artificial ceilings. It is also used to make surgical bandages, in casting and molding purposes in dentistry, in the making of statues, manufacture of crayons, etc. POP, when mixed with water, sets into a hard mass called gypsum. During this reaction, heat is liberated. This is a combination reaction. Gypsum is mainly used in the manufacture of cement. The formation of concrete and the manufacture of gypsum both involve liberation of heat. The reaction between iron and sulfur requires heat to form ferrous sulfide. During combination reactions, the reactants may liberate heat or require heat to form products. Let us perform some combination reactions to understand this better. Reaction of calcium oxide and water. Take a beaker half filled with water. Add a few pieces of quicklime or calcium oxide to water. As the reaction proceeds, the pieces of lime dissolve slowly. Now, let us touch the beaker and see. The beaker has become slightly warm. As calcium oxide dissolves in water, the temperature of water increases. Such reactions are called exothermic reactions. The reaction between lime and water gives calcium hydroxide and the release of heat. As two reactants give a single product, it is a combination reaction. Now, allow carbon dioxide gas to react with calcium hydroxide. What do you observe? The solution turns milky. Calcium hydroxide reacts with carbon dioxide to form a white precipitate of calcium carbonate and water. The formation of calcium carbonate makes the calcium hydroxide solution milky. Calcium hydroxide is also called as slaked lime. It is used for whitewashing of walls. Slaked lime reacts with the carbon dioxide in the air to form a thin layer of calcium carbonate on the walls. This layer, after 3 to 4 days, gives a shiny finish to the walls. Endothermic and exothermic reactions. Let us understand endothermic reactions. Potassium nitrate reacts with water to form a solution of potassium nitrate. In this reaction, there is absorption of heat by the reactants, hence the temperature of the solution falls. Reactions in which reactants require heat to form products are called endothermic reactions. Exothermic reactions. Sodium hydroxide reacts with water to form a solution of sodium hydroxide. In this reaction, heat is evolved. Hence, there is a rise in temperature. Reactions in which heat is evolved are called exothermic reactions. Formation of concrete and the manufacture of gypsum, which we discussed earlier, are both exothermic reactions as they involve liberation of heat. Is respiration an endothermic or exothermic reaction? Rice, potato, sago, etc. form a major source of carbohydrates in our diet. During digestion, these carbohydrates are broken down into glucose. When the process of respiration takes place, glucose combines with oxygen in our body and liberates heat and energy. It is this energy which is used by our body to carry out various activities. Thus, we can classify respiration as an exothermic reaction. Let us perform an activity to understand the next type of reactions, that is, decomposition reactions. Decomposition reactions. Activity: take some sugar in a porcelain dish. Heat it. It turns brown in color. Heat it further. It becomes a black solid mass. Sugar has become charred to give this black solid mass. Sugar is a carbon compound. When sugar is heated, it loses all its water molecules and what remains is carbon. A single compound decomposed or broke down to give two products. This is a decomposition reaction. In this reaction, sugar molecules are decomposed by the action of heat. Hence, this reaction is a thermal decomposition reaction. In the manufacture of cement, calcium carbonate is heated at a temperature of 1000 degrees Celsius. At this stage, calcium carbonate decomposes to calcium oxide and carbon dioxide by the action of heat. Let us perform an activity to understand some more types of decomposition reactions. Activity: take some silver bromide on a watch glass. It is pale yellow in color. Now, place the watch glass in sunlight. Observe the color after some time. The pale yellow silver bromide has turned grey in color. Silver bromide has changed to metallic silver due to the action of sunlight. A similar observation can be made using silver chloride. Silver chloride, when exposed to sunlight, also changes to metallic silver. Silver bromide and silver chloride are used in photography during the process of developing of photograph negatives. This is because silver salts, when exposed to light, turn to metallic silver, which block light and appear as the black part of the film negative. In laboratories, these compounds are stored in dark-colored bottles to protect them from light. Can a decomposition reaction be carried out using electricity? Yes. Let us see whether water can be decomposed using electricity. Electrolytic decomposition of water. Take acidified water in a voltmeter. Pass electric current through it. Water splits or decomposes into hydrogen and oxygen. This decomposition is brought about by electrical energy. Hence, this reaction is known as electrolytic decomposition or electrolysis. Water can be decomposed into hydrogen and oxygen by the process of electrolytic decomposition. The electrolysis of water produces 2 volumes of hydrogen gas and 1 volume of oxygen gas. This shows that the water is a compound made up of 2 parts of hydrogen and 1 part of oxygen by volume. Displacement reactions. Take a solution of copper sulfate in a beaker. Dip the zinc strip in the solution. Remove the strip after 5 minutes. What do you observe? The shiny strip has got a red coat of copper over it. The copper sulfate solution has also become lighter in color. What is the reaction? Zinc displaces copper in copper sulfate to form zinc sulfate. Such reactions are called displacement reactions. Reactions in which the more reactive element displaces the less reactive element from its compound are called displacement reactions. If a strip of iron is dipped in a solution of copper sulfate, a red coat of copper is seen on the iron strip and the blue-colored copper sulfate solution turns green. Iron, being more reactive than copper, can displace copper from its solution. Lead is another metal which is more reactive than copper and can displace it from copper sulfate. Let us discuss the next type of reactions, double displacement reactions. Double displacement reactions. Activity. Let us perform an activity to understand double displacement reactions. Take about 5 ml of copper chloride in a test tube. Add 5 ml of potassium iodide solution to it. Copper chloride reacts with potassium iodide to form insoluble copper iodide and potassium chloride. What do you observe? There is a brown insoluble substance formed. This insoluble substance is called a precipitate. So this reaction can also be called as a precipitation reaction. There are certain reactions in which ions of the reactants exchange places to form two new compounds. These are called double displacement reactions. Let us consider some more reactions. Reaction 1. Sodium chloride reacts with silver nitrate to form a white precipitate of silver chloride and a solution of sodium nitrate. The nitrate ion and the chloride ion exchange places to form the precipitate of silver chloride. Reaction 2. Barium sulfide reacts with zinc sulfate to form a white precipitate of barium sulfate and zinc sulfide. The sulfide ion and the sulfate ion exchange places to form insoluble barium sulfate. Oxidation and reduction. Let us recall this experiment. Copper powder was heated to form copper oxide. In this reaction, copper gains oxygen to form copper oxide. What type of reaction was this? This was an oxidation reaction. Gaining of oxygen is an oxidation reaction. When hydrogen gas is passed over black copper oxide, the black copper oxide is converted to copper. What type of reaction is this? This is a reduction reaction. Copper oxide loses oxygen to form metallic copper. We can say that copper oxide is reduced to copper. You can observe that in this reaction, hydrogen combines with oxygen to form water. Hydrogen is oxidized to water. Here, reduction and oxidation reactions take place simultaneously. Such reactions are called oxidation-reduction reactions or redox reactions. Redox reactions. Let us consider some redox reactions. In a reaction between barium sulfate and carbon, barium loses its oxygen atoms to form barium sulfide and carbon gains oxygen to form carbon monoxide. In other words, barium sulfate is reduced to barium sulfide and carbon is oxidized to carbon monoxide. In the reaction between hydrogen sulfide and sulfur dioxide, sulfur and water are formed. That is, hydrogen sulfide is oxidized to sulfur and sulfur dioxide is reduced to sulfur. When one reactant is oxidized, the other reactant is reduced. Here, reduction and oxidation reactions take place simultaneously. Such reactions are called oxidation-reduction reactions or redox reactions. We see the effects of several oxidation reactions taking place around us. Effects of oxidation in everyday life. Corrosion. Take a look at some unused iron nails and iron screws at home. What do you observe? Iron nails and iron screws that were shiny when they were new are now covered with a reddish coating. Why does this happen? When iron nails and iron screws are exposed to moisture, iron combines with oxygen of the air in the presence of water to form hydrated iron oxide. The chemical formula is Fe2O3xH2O. This process is commonly called as rusting of iron. The red layer formed is rust. The chemical formula of rust is Fe2O3xH2O. This slow process of decay and destruction of metals due to the action of air, moisture or acids is called corrosion. Some other metals like copper and silver also get corroded when exposed to light and moisture. Copper articles, when exposed to air and moisture, develop a green coating over them. Copper reacts with carbon dioxide from the air to form a green layer of copper carbonate, CuCO3. In the same way, silver reacts with hydrogen sulfide in the air to form a black layer of silver sulfide. Corrosion damages buildings, bridges, ships, automobiles, and other articles made of iron. Hence, prevention of corrosion is necessary. This will not only save money but can also prevent accidents from taking place. Prevention of corrosion. Corrosion can be prevented by using anti-rust solutions, painting surfaces with paint, and using methods like electroplating and galvanizing. Painting forms a protective coat on the metal surface. This coat prevents the metal from coming in contact with oxygen or moisture from the air. Galvanizing is a process of coating zinc on iron or steel to prevent it from corrosion. Electroplating is a process in which a metal is coated with another metal using the electrolysis technique. Iron or steel articles are electroplated with chromium or nickel to prevent them from rusting. Do food items also react with oxygen and get spoiled? Yes. When food items like oil, ghee and butter are allowed to stand for a long time, they smell foul. If food is cooked in such leftover oil, ghee or butter, the oil froths and the food tastes different and unpleasant. This happens due to the process of oxidation. Oils and fats react with oxygen and become oxidized or turn rancid. This process is called rancidity. Rancidity. Rancidity can be prevented by keeping food in airtight containers or by using antioxidants. Two common antioxidants used in food to prevent oxidation are BHA, butylated hydroxyanisole, and BHT, butylated hydroxytoluene. Antioxidants are substances used to prevent oxidation of food containing oils and fats. Vitamins are natural antioxidants. The best source of vitamins is fruits and vegetables. Fruits like oranges and berries like strawberries and raspberries are rich in antioxidants. Antioxidants strengthen the immune system and fight aging. Do you know how chips remain fresh in airtight containers? Chips are packed in bags containing an unreactive gas like nitrogen, which prevents chips from getting oxidized. Oxidation of foodstuffs can be slowed down by keeping food in a refrigerator, storing food in airtight containers, or storing foods away from sunlight.